All right, hello everybody. Away we go. We're going to start reviewing for. There we go. We're going to start reviewing for the final / AP test, and information on the AP test is still forthcoming. Not exactly sure what's going to go on with that, but it sounds like, and I don't know this for sure, they're going to use AP Classroom for to administer the test. So I'm sure all of you have logged into that. But what I think I'm going to do is make an assignment in there so that you actually have to go in, make sure you can log in, make sure you know your password, so that when that AP test rolls around, um, you're not scrambling to find all that in a panic, so that we know how to access it. So I'm gonna unmute as long as there's not a ton of background noise. If there is, I'll just mute you all again. But I think you can unmute yourself on your picture. So if you are muted, I think you can always unmute and ask me a question, stop me, slow me down, whatever you need to do. The notes are a little long today for a half-hour period, so if there's no questions, we're going to jump right into it. I'm going to get going here. And I need calculator. Move you guys off to the side. I have two monitors, so I moved all the videos off to the side there. All right, here we go. We're going to start out with area and volume. Chapter 8, everybody's favorite chapter. We're going to just rip the Band-Aid off right away. Let R be the shaded region bounded by the graph of x e to the x squared. That's this curve right here. The line y equals negative 2x. That's the line down there. And the vertical line, x equals 1. So there's x equals 1. As shown in the figure above or off to the right. A, find the area of R. So A, we're going to integrate from 0 to 1, of top minus bottom. So x e to the x squared, and then minus the bottom is negative 2x. So plus 2x dx. Now this is a non-calculator problem. So we're going to do, for just this piece right here, we're going to do u is equal to x squared, and du is 2x dx. But we don't have 2x dx. Remember, we're not looking at this second one yet. We have x dx. So we have 1/2 du is equal to x dx. Well, now this piece becomes the integral of 1/2 e to the u du. So the x dx becomes 1/2 du, e to the x squared becomes e to the u. So the antiderivative e to the u is e to the u, but that's going to be 1/2 e to the x squared, because that's what u is. And then plus x squared. And we're integrating from 0 to 1. Now when we plug 1 in, we get 1/2 e plus 1. But then when we plug 0 in, e to the 0 is 1. So minus 1/2 and then plus 0. So we get e over 2 plus 1/2 minus 1/2 is a half. I think the way they write is e plus 1 over 2, common denominator. Right, but do not evaluate. All right, I'm going to write that down here, I suppose. B, an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals negative 2. Well, this line is negative 2x. So from here, we'd go down 2 and right 1. So the point is, this is down here at negative 2. So we're going to rotate this about the line y equals negative 2. So let's get the 180-degree rotation like that. And then like this, something like that. We're going to rotate this inside one around and rotate the outside one around, so we have a washer. So we need to integrate from 0 to 1 of big R squared, or the big radius, minus the little radius, dx. Dx because these are all vertical to the x-axis. We need the big radius. Well, that's the top minus the bottom. Top minus bottom. So that's going to be x e to the x squared minus -2 or +2 because we're down here at y equals -2. That's the big radius. And then the little radius is this line minus -2. So -2x plus 2. Squared. Squared. Any questions on that one? Letter C. Right, but do not evaluate an expression involving one or more integrals that gives the perimeter of R. Let me erase all this junk here. Need the perimeter. How about, let's start with this side right here. And that is the hypotenuse of that triangle. So that's 2 units, that's 1 unit. This isn't to scale, by the way, as you can tell. So the perimeter is equal to the square root of 4 plus 1. 2 squared plus 1 squared. Pythagorean theorem. Then this side right there is 2 units down. So that has a length of 2 units. This up here is the point 1 comma. If you plug 1 into that function, 1 times e to the first is just e. So this length right here is the y value. It's e. So plus e. So I got, I'm just working my way around the area. Now I need the length of this curve. So plus the integral from 0 to 1 of the square root of 1 plus, and I need the derivative squared there. I need dy dx squared in this place right here. But it's a derivative of that curve. So dy dx is equal to first times the derivative of the second. So there's a derivative of the inside, chain rule. Plus the second times the derivative of the first, which is 1. So we can factor out an e to the x squared, and that's 2x squared plus 1. There's the derivative. But in here is the derivative squared. So e to the x squared, 2x squared plus 1 squared. We should probably have dx. Now, of course, they're going to write this as the square root of 5. So just a little bit of simplifying. Length integral from a to b, square root of 1 plus dy dx squared. That's the length of a curve. Any questions? I have a little bit, I did this last period. Not a big deal. 1 for the integrand, so 1 for all of that right there. 1 for the antiderivative and 1 for the answer. That's pretty straightforward. 2 for the integrand, maybe 1 for each of those. And then 1 for having the limits and the constant. Here, we needed to show the derivative, so they're looking for that for 1 point. They want the integral, and then the rest of this is probably worth 1 for the answer. Let R be the region in the first quadrant bounded by the x-axis in the graphs of y equals a natural log of x. So here's the natural log of x. And then y equals 5 minus x. So that piece is 5 minus x. Find the area of R. We're going to do this in 2 different ways. So we're going to do the integral. Well, here's what we got to do first. This is definitely a calculator problem. So we're going to do y equals natural log of x and 5 minus x. I'm going to get the window. X is going from 0 to 5. And y is going from, we'll go 0 to 2. We'll widen it out a little bit more than just 1. So when we graph, there's the natural log of x. Here comes 5 minus x. We need that intersection point. It's not nice. Calculate. Intersection. First curve, second curve. Here it comes. I'm trying to get it there. There we go. Guess about right there. And so now if we label this, we'll go, this is the point, 3.693, 1.306. And if we say A is equal to 3.693, how about a little farther? 4414. And B is equal to 1.30655586. Then we need to split this area. So the first part of the area is traveling along natural log of x. It's under that curve. But then once we get to the intersection point, now the area is under 5 minus x. So we're going to integrate from 0 to a of natural log of x dx plus the integral from now from a to 5 of 5 minus x. All right, so let's get that answer. And we can integrate, math number 9, we can integrate from 0 to, now remember the variable x is still holding that value. And we'll do, we can do this, variables, y variables, function. Natural log of x was y1. Now that x is different. That one's not a value. That's saying integrate with respect to x. Plus math number 9 from a, or the x coordinate that we calculated, to 5 of variables, y variables, but we want y2 now, dx. .985 or 1.986. Now we need to do this a little different way. And actually the second way is going to help us with letter C actually. Instead of going under the curve this way, we're going to say this is the right curve and this is the left curve. Instead of taking, remember, we can find area with top minus bottom. Well, if we're integrating with respect to y, we can do right minus left. So integral from 0 to, now we're integrating with respect to y, 0 to b, of the right function minus the left function, but we need them in terms of y, not in terms of x. So I need to switch that curve right there. So x is equal to e to the y. And we need to switch these. So y plus x is equal to 5. No. Y minus 5 is equal to negative x. Don't ask. X is equal to 5 minus y. So the right curve is now 5 minus y. And the left curve is e to the y. So minus e to the y dy. So now when we go math number 9, go from 0 to y of, now the variables in here don't really matter as long as I keep this the same. So I can do this. I can go 5 minus x. It doesn't have to be y minus e to the x, as long as I say I'm integrating with respect to x. So this y up here is not really the y variable, it's the value, and then I'm just using x's for the valuation. So enter should be, gosh dang it, what happened? What is y1 and y2? Natural log 5 minus x. I don't have time for this. Why is that 2 different values? Let's try this. I don't know why. Math number 9. Sorry about this, you guys. 0 to 0 to x. Let's just do natural log of x. It was the same. I did it this way last period, and it was the same answer. So math number 9, x to 5 of 5 minus x. dx.
Mr. Smith, I think looking at the answer key, it integrates from 1 to A, not 0 to A,
What?
like on the
Oh,
SR2 at the
yes.
bottom.
I don't know, you guys. If I figure it out, I'll post a video saying which one is the right answer. 2.985. This one's the wrong one. 1 to A. That's exactly what I'm doing. 3.69344. I'm typing in something wrong. Anybody see it?
You integrate with 0, not you have it
I sure
as
don't.
0, not 1.
I'm using parentheses correctly. Wonder what is it telling me? And I don't have time for this. Oh, I kind of do. 3 point. Boy, I don't know, you guys. I'm at a loss. You know, it's the process that I want you to know. So I'm going to move on. It worked for me perfect last period. I don't know what I'm doing different. Letter B. Region R is the base of a solid. For the solid, each cross section perpendicular to the x-axis is a square. So now each of these is the base of a square. So remember how we lay this down. It's like this and like this. And then we have squares coming up like that. So what we do is we integrate side squared, but with respect to x, because these are perpendicular to the x-axis. So now we're going to integrate from 0 to a of natural log of x squared, because natural log of x is the side now, and we'd have to square the side. Dx plus integral from a to 5 of 5 minus x squared dx, like that. And then finally, letter C, the horizontal line y equals k divides R into two regions of equal area. Write, but do not solve an equation involving one or more integrals whose solution gives the value of x. So in other words, there's some k value, that cuts this area in half. Now we're not saying it's 1/2, and it's not very symmetrical, so it probably isn't 1/2. But there's some k that cuts this area in half. So if we integrate from 0 to k of right minus left, or the area, which is 5 minus y. It is still 5 minus y. I don't know why that answer is wrong. It's going to be bug me all day now. Dy, that should be equal to half of, well, I better get the correct area, which is 2.985 or 2.986. So there's some k value that cuts this in half, and this is how you would set up the equation there. Any questions on that one?
Mr. Smith, for A, you do 0
All right,
to
so
A, but I think it's
there's the answer. I don't know why I can't get that to work, but I can't. There is the volume, where we have to, this is the base squared, this is side squared, this is side squared, and we're integrating side squared. And then we have 0 to k, and that should equal half of the area. And you see they have one for if you round, one if you truncate. All right, how about more towards the multiple choice that we're going to see on this first quiz? So what is the slope of the line tangent to the curve? X squared minus 2xy minus 5y squared equals -15 when y equals 2. So slope of the line tangent. So we want dy dx. So the derivative of this is 2x minus first times the derivative of the second plus the second. So plus the second, but the derivative of the first is -2. So minus 2y. And then minus 10y dy dx. This is implicit differentiation. And don't forget to take the derivative of that constant over there. That's going to be 0. Don't leave it as negative 15. So let's factor out, well, let's get this over to the other side. Let's get this over to the other side. And then on the what remains, we'll factor out a dy dx. That's negative 2x minus 10y is equal to 2y minus 2x. So dy dx is equal to 2y minus 2x over negative 2x minus 10y. And what we could do, and you don't have to do this, is divide everything by 2. Negative x minus 5y. But we want to evaluate that when y is equal to 2, but we have x's in here also. So let's plug 2 in for y up here. X squared minus 4x minus 20 is 4 times 5 is equal to negative 15. So x squared minus 4x minus 5 is equal to 0. X minus 5, x plus 1. So x equals negative 5, x equal, no, positive 5, x equals negative 1. So let's evaluate this at the point 2, 5. So 5 minus 2 over negative 2 minus, oh, wait. Yeah. Oh, no, I switched those, didn't I? Geez, you guys, you can let me know if I mix it up. It's 5, 2. X is 5, y is 2. All right, so 2 minus 5 over negative 5 minus 10. Negative 3 over negative 15, so 1/5. 1/5 for that one. How about evaluate at negative 1, 2? So 2 plus 1 over 1 minus 10. 1 minus 10. 3 over negative 9, so negative 1/3. That's what we're looking at. And the whole point of that is the implicit differentiation. How about some u substitution on this one? We'll let u equal 1/6 x squared plus 1 because I see a function and I see its derivative. So u substitution, find a function and at least a multiple of its derivative. So du is 1/3 x dx. But I don't have 1/3 x, I just have x. So we have 3 du is equal to x dx. So I can replace x dx with 3 du. So 3 integral du. And then 1/6 x squared plus 1, replace that with u. But now we could do the integral and turn everything back into x's, or we can turn the x's into u's. See, those are x's. Now, if we convert them to u's, we don't have to go back to x's. So if we plug square root of 18 in for x, that's going to be 18 divided by 6 is 3 plus 1 is 4. Plug 0 in there, we get 1. Now, you don't have to do this. You can go back to x's if you'd like. Well, square root of u is u to the 1/2. Add 1. That's u to the 3/2, and then times 2/3. But so there's the antiderivative, but we're multiplying by 3. So I'll cancel out that 3. So 2 u to the 3/2 from 1 to 4. So the square root of 4 is 2. 2 to the 3rd is 8. So 2 times 8 minus 2 times 1. So 16 minus 2, 14. We have 4 minutes. The derivative here, just practice with the chain rule, is, no, product rule, excuse me. First times the derivative of the second, which is 3e to the 3x, plus the second times the derivative of the first. And we can factor out an e, 3 to the x, and an x, excuse me. So 3x plus 2 is how you probably see it on AP because they like to factor stuff out. So now we're going to continue on, and I'm going to throw up a video as soon as I get done here. I'll throw this Zoom video up. I'll throw a video of the next topic, which I believe is charts. And we're going to move on. Now, each worksheet has 3 problems on it, and I'm going to cut that back to the assignment is the first 2 problems on each worksheet up into the time we take the quiz. You can do the third one if you'd like, and that'd be great practice for each topic, but I'm going to leave that up to you because you know where you're at with the class, you know how much you understand, you know if you're getting them right. If you need to practice that third one, go ahead. If you don't, I'm not going to assign it. So the Google assignment that I'm going to put up on Google Classroom will be for the first 2 problems rather than all 3. So I'll cut you a little break here because of the unusual circumstances that we're working with. So I think we're looking at a quiz on, what is today, Wednesday? I think we're looking at a quiz on Monday. The free response will be 2 of the 3 topics that we'll cover this week. I'm in the process of grading your tests. Those take a while just by the nature of how we turned it in. And I'm going to get those done as soon as I can. And as I grade them, I don't know if you'll see the grades or not. I'll have to play around with that. I'll get back to you on that. Are there any questions? So you'll have to do 2 free response today, tomorrow, and Friday. Actually, you're going to be doing 2 free response pretty much every day. But of course, you'll have the weekend to do some of those as well. Any questions on expectations? I see, do we have 3 chat messages? Can we do? Matt, I don't have a song ready. You're integrating from 0 instead of 1. Oh, I shouldn't be integrating. Oh, that's it. That's why I was getting a wrong answer. Thank you. I was integrating from 0 to A rather than 1 to A on that problem. That's exactly what it was. Thank you for that. How will the assignments be graded? Completion grades as usual. I will not grade right or wrong because I throw the answers up there. And of course, you can look at the answer. Now, with that third free response, even if you don't write it down, you can at least go look at the rubric and read it a little bit and maybe get something out of that. My headphones on? Zoe, say hi.
Hello.
Yeah, I don't think you can hear us.
Oh, hey, I can hear you guys now. I've had my headphones off the whole time.
Yeah, we were trying to correct.
Oh, you're
Yeah.
trying to yell at me the whole time, probably. Boy, I'll tell you what. I
I
don't
thought
know.
you were just ignoring us.
Yeah, well, I was. No, I wasn't. My headphones were off the whole time. You're probably screaming, "You're going
Yeah,
from
that's a little
0!
embarrassing.
Don't go from 0!" Oh, brother. No wonder you guys. No wonder. Okay. Anyway, I'll remember to turn those on from now on. Maybe. I probably won't. Are we supposed to upload each homework assignment as a PDF? I mean, I sure would like that, but that really wouldn't be necessary. The only time I absolutely need a PDF or would want a PDF is if we're doing quizzes or tests. That way, in case I want to print them out, it'd be much easier to print them out with a PDF rather than a picture. So, no, not necessary for assignments. Anything else for the good of the cause? Because we're at 2:30 now.
So with the quizzes, are they gonna be print off and then scanned back in just like the test was?
Yeah, I'm going to do it just like the test. So if you have the ability to print them off, I'm sure that's handier for you guys. Otherwise, you can just put them on notebook paper. Some of you put them on notebook paper, which is fine. They are AP style quizzes, which means they are scaled, which is usually good news. That my classes usually get good grades out of those. And the scale's massive because there's not very many points on them. They're fairly short. Well, they're 8.5 by 11, like everything else. That's a joke. You guys know what I mean. Anything else before we hit takeoff? All right, you guys. Have a great day. Stay safe. Stay healthy. And keep doing the assignments. If you have any questions ever, email me. I'm always checking my email because of the situation we're in. And I'm just an email away. Whatever you need to do. So have a great day. I'll see you guys later.
Thank you.
All right.
Thank
Bye.
you.
Thank you.
Bye.
Bye-bye.